Hello, welcome back, peeps. We are again working on 4.7, so please try this first example on your own. Pause the video and let's see how you did. Okay, peeps, here we go. This is what your graph should look like. I'm not going to go through the steps. I want to make sure you know what you're doing, so I'm going to put just my vertical, horizontal asymptotes there. I have a couple points that I found. Here and here. And something to note, because this is an even function right here, an even asymptote in a way, come on, I can write it and show that they're both going to go the same direction. So this one, I approach from the left going up. Same thing over here, I'd approach going up. You do need an XY table because I do need to see at least 1 to 2 points in each area. Because it's even, it goes up together. If you have questions on that, please ask me during class. Now, we're going to talk about example number 1 together. Again, I just have my steps right next to me. I'm going through those rules step by step. First one, factor the top and bottom. Well, I can factor that. I can take a GCF out on the top. I can factor the denominator. Nothing canceled, okay. So vertical asymptote is the way to go. Vertical asymptote, you set the denominators equal to 0. So I would get x equals 4, x equals -1 as my asymptotes. Something to note is that they're both odd power. So maybe right next to them, write odd, or when you actually graph them, put odd. This will just help you as you're creating your function. So odd. 1, 2, 3, 4. Okay, horizontal asymptote has 3 cases. If you notice, the power on the top and the bottom are the same. So I just take the ratio of the coefficients, which is 1 and 1. So horizontal asymptote is y equals 1. X-intercept, where the numerator equals 0. Hopefully you see that I'm already in factored form, so when I do x-intercept, I can do a nice zero product property. X minus 2 equal to 0. So I get the intercept of 0, 0 and 2, 0. So 0, 0 is right here, 2 zeros there. Y-intercept is where x's are 0. So I'm going to go back to the original this time for my y-intercept. Again, no preference on which way you do it. I just always try to pick the easiest. So that's 0, 0, 0 squared, 0 minus 4. Well, it's a lot. So my y-intercept is 0 divided by -4. So 0 divided by -4 is just 0, 0. Which is actually the same point as my x-intercept. So totally okay. Kind of they have both colors in a way. Moving on, multiplicity. Well, we know both of them are odd, so we're going to approach in different directions. But this isn't a lot for me to tell me what the graph's going to look like. So I need to do my XY table. Okay, let's plug in some points. You want to pick some points in each area to figure out what the curve's going to look like. So I'm going to pick like -2. X of -2. If I plug that in, -2, I get like 1.33 or 1 1/3. So 4/3 if you want. So -2, 4/3, 1 1/3. So there's that point. If I plug in maybe like 3, I don't know, random points, guys, whatever points you want. If I plug in 3, I'll get -3/4. Okay, so that's kind of telling me I might be going down. And then a point to the right of my vertical asymptote, I'll plug in 5, and I get 2.5. Okay, so looking at this, I'm getting the idea that my graph is going to go like this, and this one will also go up, which means both of these asymptotes here need to approach going down because it's an odd power. They have to go the opposite direction. But I need to know what's happening in this middle area. I don't know much. So I'm going to have to set it equal to the horizontal asymptote and find out if it crosses. So I'm going to clean this up a little bit. I'm going to do step 8, you know, that horizontal asymptote. So I'm going to take my function. It doesn't matter which one. I might just do the original function. So the x squared minus 2x all over x squared minus 3x minus 4, and set it equal to my horizontal asymptote, which is 1. Okay, right here, horizontal asymptote is 1. Set that equal to my function, because I'm trying to find where it crosses. Well, here I'll put this over 1, do a nice cross multiplication action. This turns out pretty nice. Oops, that's a 4. Because these will cancel when we subtract. Then I can add over a 3x and get x equals negative 4. That doesn't make sense. Oh, maybe it does. Totally fine. It says it crosses at negative 4, so it's the point negative 4, comma 1. Kind of weird. So my idea over here, negative 1, 2, 3, 4, it's actually going to cross right there. So I'm going to erase this part. It's going to cross, but then hug very closely to that asymptote. Again, it doesn't tell me that it's going to cross in my middle area. So all I know is that it's going to go up and come right back down. Kind of interesting, right? You have an idea, but then once you solve a little further, it might change your answer. Heading to the back, we're now going to talk about these slanted asymptotes. So these are different horizontal asymptote. This is option C from our little sheet that we use. This is what happens when the degree of the numerator is bigger than the degree of the denominator. Okay, this is option C. So degree, numerator, bigger than degree of denominator. Let's take a look. Step 1, as always, factor. This would be x plus 2, x minus 2, all over the bottom of x minus 2. Holy guacamole, we have a whole now. Right, I can cancel these out, which means I have a whole at 2. Okay. To find the y value, we'll talk about that in a moment. Okay, so we have a whole at 2. We won't forget that. In the end, my equation simplifies out. I'm actually going to move this over here. Simplifies to just y equals x plus 2. Wow, that's really nice. Because everything canceled out, so this is what's left. Guys, that's just a line. Slope of 1, start at 0, 2. I can do that. Up 1 over 1, up 1 over 1, up 1 over 1. Down 1, down 1, down 1, down 1. So here is, oops, whoa, golly. Here is my line. Now one thing I have to remember, this whole, and that is very common. I wanted to show you I would go all the way through to the bottom and then forget. So I'm going to erase that. I'm going to put a nice hole here. Maybe you should erase the line as well so that you don't get confused or don't confuse the person that's grading. And this would be your equation. Okay, a hole is at 2, 4. make sure it is a geometric hole. So that is your slant asymptote. That's actually the only curve that it's going to fit on. And I actually wouldn't call that a slant. I would call that just a linear line. Let's go to this next one. Let's follow the same steps. Factor the top and bottom. Oh, actually you can't, right? We don't have a sum of perfect squares. So I actually can't simplify this at all. My vertical asymptote is when the denominator equals 0, so that's at x equals positive 1. And now I look at my horizontal asymptote. I notice the degree of the numerator is bigger than the denominator. So that means I have a slant or oblique asymptote. So I actually need to do some long division. I'm going to take the denominator and divide it into our numerator. I am going to put a place value here. Whenever you guys do long division, remember you need a place value for all the terms. So I'm just going to put that 0x in there. And now let's do some long division. X times what will give me x squared? Well, that would be x. So I'm going to multiply x minus 1 by the x. Get x squared minus x. Remember, when you're doing long division, you have to subtract the entire thing, which then will cancel there, and you will have a positive x. X times what will give me x? Well, that would just be a nice plus 1. So then you multiply x by 1, negative 1 by 1. Again, you're subtracting the whole thing. So that means your x's will cancel. You can think of this as a, oh, I'm sorry, this plus 1 needs to come down with it. Ooh, almost forgot that. X's will cancel. You get 1 plus 1, which is 2. That is what's called your remainder. So your answer is x plus 1 with a remainder. Come on. Of 2. That is your horizontal asymptote. Now the remainder of 2 is not actually super critical at this point, so we're just going to kind of ignore it and just realize that x plus 1 is my vertical, horizontal, oblique, slant asymptote. Well, it just means you graph that. You go 0, 1, and then a slope of 1. So it's this dashed line right here, trying to make it as straight as possible, is my oblique asymptote. It's going to hug my graph. I'm now going to jump into some XY tables. Next, I need to figure out where is this graph, what's happening. If I plug in 2, I get 5. Okay, so it's something up there. If I plug in 0, we're trying to find that y-intercept, I'm going to get negative 1. So now here's my graph. I know right here this is an odd vertical asymptote because this power on the bottom is 1, so they have to approach in different directions. So if this one approaches down, this one needs to approach up. Kind of a little bit off there, sorry guys. That's how you would graph it, just a new line to hug your curve. Okay, last but not least is a partner challenge. Please group up, get with people, have a Snapchat party, do something to try this partner challenge together. I will be awarding some extra points if we get it all correct, but you're now going the opposite direction. Okay, we've talked about this before. Look at your intercepts. Is it a positive or negative function? We're back to polynomials, so think back. Wow, that was a while ago. Think about your positive, negative, intercepts, all that fun stuff. Good luck. Bring this to class next time I see you, and I'll award some points. Good luck, my dears.